Hello students, I'll be explaining distance time graphs in this video. I guess you know what distance is. The length of path covered by a body from one point to another. And one of my videos, I took time to explain the distinction, the differences between distance and displacement. Now this is distance time graph. We plot the graph of distance against time. Now the first one, if the graph is like this, the distance time graph is parallel to the time axis. I can put a value here, let's say 5. It means that this body number 1 is at rest. The body is at rest. It's like the body must have covered a distance of 5 meters. After that, no, the position of the body did not change. You can see that after this time, let's put this 2 seconds later, the body's position or distance is still 5 meters. After 4 seconds, it's still 5 meters. So this is a case where the body is at rest, and therefore the speed of the body is equal to 0. It's just like when you move from one point to another, and when you get to the other point, you decide to just sit down, maybe sit down in your classroom learning. So all the time you spend learning in the classroom, sitting down, you know, your position did not change. So it therefore means that the graph of your motion is like this, and your speed is 0. Now that's the graph of 0 speed. Now how about if you have this kind of distance time graph? A distance time graph that looks like this. This is a graph of distance d in meters against time. And the graph is a straight line that starts from the origin. Okay, in this case, you see the body's motion starts from the origin. And how is it moving? Let's say at a point here, after 5 seconds, the distance corresponds to 20 meters, which means this body covers a distance of 20 meters in 5 seconds. And since the graph is a straight line, we can see that the slope of this graph, first of all, represents the speed of the body. The slope of the graph represents speed. And a straight line graph with a positive inclination, with a positive angle of inclination to the time axis, that straight line graph has a constant slope. So the slope is constant. Since the slope is constant, and the slope is speed. So it's very logical to say that the speed is constant. The speed of the body is constant. Here I said again that the slope is speed. And seeing the slope of a straight line graph that has a positive inclination is constant, it's very logical to say that the speed of the body is constant. So this is a graph of constant speed, and we can calculate the value of the constant speed because the slope of the body is defined by the change in the vertical parameter. This is change in distance over change in time. You can decide to use 2 points. This is point 2. I can call that point 2. I can call this origin point 1. And then I draw a slope triangle like this. It's a right angle triangle, and I can use that my right angle triangle to calculate the slope of this graph. So that gives me change in that slope, which is equal to the speed of the body, is given as change in distance over change in time. So that gives me 20 minus 0. That is this point here is 0 over this point here is 5 seconds. 5 minus 0, that gives me a slope of 4. And since my slope is speed, it means that this constant speed the body is moving with is 4 meters per second, which means the body started its motion from rest and moved at a constant speed of 4 meters per second for 5 seconds. Now, again, speed is the rate at which a body covers a distance. So since it's moving, walking, cycling, riding, driving at a speed of 4 meters per second, meaning that after 5 seconds, must have covered a total distance of 20 meters. So this is a graph of uniform speed or constant speed. So a straight line distance time graph represents uniform speed or constant speed. Okay, now the third one I will show you here is suppose you have a distance time graph that is like this, a distance time graph of this nature, and then this case is just a curve with the graph curves continuously upward. This is distance in meters against time in seconds. So what do we call this kind of graph? How do we define the slope of this graph? For this particular graph, you can say that the slope is increasing. In this case, this is a graph of constant slope, but this is a graph of increasing slope. And the slope of a curve is the same thing as the slope of a tangent drawn at that point on the curve. So the different points on this curve will have different slope because the graph is not a straight line. And if I draw a tangent, because the slope of this graph is the slope of the tangent here will be different from the tangent at this other point. So different points with different tangents. So the slope of the graph at this point is the slope of the tangent at this point. And since this graph is a continuous curve, it therefore means that the slope is changing, then the speed is changing. So this is a graph of increasing slope. And since slope is speed, it's the graph of increasing speed. So we can write the graph of increasing speed. So, and if the speed increases at the uniform rate, we say this is the graph of acceleration. If the rate of increase is uniform, then it is a graph of constant acceleration. So you can see that we can represent acceleration from or with a distance time graph. We can interpret acceleration from a distance time graph. So this is a graph of increasing speed or the graph of acceleration. If the speed increases at a uniform rate, then it's the graph of constant acceleration. Okay. Then you can also have a distance time graph that is like this. I'm just showing you different sketches. In case you come across any one of them, you should be able to apply and interpret them correctly. How about if I give you a distance time graph that is like this? You can see in this case that the graph is sloping towards the time axis. This is a graph of decreasing slope. This is a graph of decreasing slope. Decreasing slope, meaning that decreasing is also a graph of decreasing speed. The slope represents speed. So whatever form the slope assumes, the same applies to the speed. Slope is speed and speed is slope. So if the slope is increasing, it means the speed will equally be increasing. If the slope is decreasing, it means the speed is decreasing. So in this case, the body is moving with a decreasing speed. That decreasing speed, if it does that at a uniform rate, it means it's a graph of constant deceleration. So on a distance time graph, this is a graph of deceleration, that is reducing speed or decreasing speed. Constant deceleration or decreasing speed. Okay, and you have seen the different types of distance time graph. We have the one that represents zero speed, which is the body is at rest. Constant speed. In the case of constant speed, you can see the acceleration is zero. When the speed of a body is constant, the body does not have acceleration. So we can see this is a graph of constant speed, uniform speed, or zero acceleration. So two things. We can look at a distance time graph and interpret it based on the speed and the acceleration. Okay, so this is constant speed, zero acceleration. This is increasing speed, constant acceleration, so to speak, if the speed increases at a uniform rate. And this is the graph of decreasing speed or constant deceleration. Now, how about if you have to interpret this graph? Let me um, now we have this drawn. This graph is drawn on a displacement time axis. This is, sorry, distance time axis. So let's say for about let's say 4 seconds, this point corresponds to a distance of 10 meters, and then we have this point corresponding to a time of 6 seconds. So how do we interpret this graph? Because if you're not careful, you'll be thinking the body is accelerating. Take note, this is a distance time graph, not velocity time. So in this case, you say the body at first is moving with a constant or uniform acceleration or uniform speed. Sorry. At first, the body is moving with a constant or uniform speed because this is a distance time graph and the slope of a distance time graph represents speed. So the uniform speed this time around is given by change in displacement, that is to say, using the slope method. Draw your slope triangle. This is 10, 10 minus 0 over, that gives you 10 minus 0 divided by 4 minus 0. Okay, so that gives you 2.5. The slope is 2.5, therefore means that the speed of the body, which is uniform, is 2.5 meter per second. So you can see that from time t equals 0 to time t equals 4 seconds, the speed of the body is constant and uniform. The acceleration is 0. Please take note, the acceleration is not constant too. So the body moves with a constant speed for 4 seconds. In the first 4 seconds, the speed is constant. And let's call this point A, and let's call this point B. From A to B, we can say that the speed of this body, becomes 0, which means it's like after the body got to point A, it stopped movement, it rested, it's no longer in motion after point A. So from point A to B, the body is not in motion. Please take note, it's at rest. So its speed is 0, you know. So it's only in motion in the first 4 seconds. And then lastly, let's look at this again on a distance time graph. Now, suppose you are sent on an errand. Mommy asks you to go to a shop nearby to get some stuff. Maybe you got to buy some bread. You left your house here at point O, and then let's say you ran to the shop, and then you got there. They have to attend to you for some time, and after attending to you, you have to run back home. So we can use this graph to describe your motion from when you leave your house to when you return back to your house at this point. Let's say point, this is A, this is B, this is C to point C on a distance time graph. So now if this point is, let's say 5, and this is 20, you see, and then let's say this point is 10, and this point is 14, that is the time here is 14. So what does it mean? You left your house at point O, and then you are going to point A to buy some bread. So which means point A is where the shop is. So you run from your house to the shop with a speed of 20 over 5, which is 4 meters per second, because the distance from your house to the shop at A is 20 meters. Look at 20 here. So your speed, since you got there in 5 seconds, your average speed running or walking, your average speed is 20 over 5. That is 4 meters per second. So when you arrive at the shop at A, between 5 and 10 is 5 seconds. Probably it took them 5 seconds to attend to you, to give you the whatever you needed, and to collect the money and to package it and all that. So you collected it at point B, the bread, and you decide to run home, from B to C. So when you get to point C, it's more like you are back home. This point C, the same thing as point O. So at point C, because of the direction, look at it, this means that your direction is reversed. A speed time graph, a distance time graph of this nature means change in direction. This is when you were going to the shop to buy the bread, and this is when you were returning from the shop back home. So you moved again with a speed of what? A speed of, find the slope of BC. It's going to be 20 again. This is 20 minus 0 over 10 minus 14 minus 10. That gives you 4. So you run back home with a speed of 5 meters per second. So that's how you describe the journey, that is using this distance time graph. Next class, we'll look at velocity time graph.